So Friday, I asked you to finish this up. I really want to cover number 4, and hopefully as you went through number 4, you noted that the equations, or the inequalities, were all the same parabola. It's just the shading or the dashed or solid were different. Okay, the location was the same. So, letter A, dashed, shading on the outside. Letter B, dashed, shading on the inside. And letter C, solid, shading on the out. Yeah?
So I didn't, make them dashed. I all have them solid, but I wrote down, dashed above them. Is that okay?
I want you to dash them. Okay, for this, yeah, it's fine. Yeah, I sometimes make mistakes and forget that I'm using a pen. That's bad. All right, any questions there? Hopefully that didn't take you too long. Okay. What I'd like you to do now, though, is I want you to go ahead and open your student journal up to page 73. Okay. And on page 73, I want you to start with 1 through 4, and you can continue on to 5 through 8 if you want. But for now, we're going to go through 1 through 4 here in a couple minutes. Go ahead and match them up. Work with your groupie. If you need help, ask me as I'm walking around, please. Here's what I've got. In terms of A, or number 1 goes with equation A. And you'll notice that all the y-intercepts negative A, so that wasn't terribly helpful. However, B and D both open downward because the A term is negative. So that's kind of helpful. And these two are dashed. Both the ones that open up and both the ones that open down are solid. So what we could do, though, is really recognize the shading. So you could test 0, 0, and we referenced that the other day. If I put 0 in for x and solve it, okay, so 0 plus 0 minus 8, and then 0. So you'd have 0 is less than or equal, or is less than negative 8, which is a true, or is a false statement. Okay, therefore, you cannot shade over that point. Okay, you'd have to shade on the outside, versus over here when you plug 0 in. 0, so you have negative 8, you have 0, so 0 is greater than negative 8. That is a true statement. Therefore, you shade over that point. Now, one thing I talked to you about last week, and I'm going to reference more today, is that, and it's kind of hard to see that this, so in your book it's a lot easier. This is actually shaded here. Okay, mine is not different than yours, but okay. One thing we talked about last week that some of you I think understood, some of you may not have, but I'm going to reference it even more today, is if you identify your y-intercept and your value is a greater than value, then you shade up the y-axis from that point. So, for instance here, I identify the y-intercept. My value is a greater than value, so I shade up the y-axis, meaning I shade everything inside there. Versus here, my y-intercept's negative 8, and it's a less than, so I shade down the y-axis, which would be everything on the outside. Okay, the same thing over here. This one, my less than symbol, when I have y is less than, that means I have to pick the graph that shades down the y-axis from my y-intercept. Okay, which one is that? Number 4. I shade down it, meaning I shade all the stuff inside here. That shades over that. And this one, I shade up it, meaning I shade all the things that exist up there with it. Okay. Just for my benefit, how many understand what I'm saying there? Okay, that's going to help when we do graphing, when we do graph systems here in a few minutes. Okay, so I want you to move on to numbers 5 through 8. When we're doing 5 through 8, let's go ahead and make sure that you understand before you put your axes on there, you look at where your y-intercept is, or excuse me, where your vertex is going to be, and figure out where the graph's going to open up or down, whether it's going to open up or down, and that'll help you out to determine where to put your axes for each of those. Okay, you may want to just start out by focusing on 5 and 6. We'll go through those together first, but if you finish those, you can try 7 and 8. I'll be walking around. Make sure you ask if you need help. Alright, so checking out number 5 there. There we got it. Okay, note that on number 5, your y-intercept is 2. This is already vertex form, right? So the y-intercept is 2. Our h term is 0, so we're at 0, 2. Over 1 up 1, over 2 up 4. It's a dashed line because there's no equal to piece. And then, since we have a less than symbol, at the y-intercept we're shading below it, which means we're shading all this junk out here. Okay? Questions on it? And then number 6, the y-intercept for number 6 is also 0. Our h term is also 0. Okay? And we go over 1 down 5, that's our a. And solid because of the equal to. And then it's a less than symbol, so at our y-intercept we shade downward. Now if you're plugging in points, like if on number 5, if you plugged in 0, 0, that would have been fine. 0 is less than 2. That's true, so you have to shade over 0, 0. In number 6, you can't use 0, 0 because it's on the line, right? So you'd have to pick, you could try like 1, 0. If you put in 1, you get -5 and 0, so 0 is less than -5. That is false, therefore you cannot shade over that point. Okay. So if you're testing a point, make sure you're testing a point that's on one side or other on the line. Okay. All right. Questions on those two? Make sure you have the correct width of this, right? Over 1 down 5. It's always how far you go on your a term there. Okay, so number 7 and 8. Give those two go. Might help to put number 8 in vertex form. 7's already there. Or at least factor number 8. Try that as well. It really is interesting as I walk around to see how, where everyone's put their axes. So, remember your graph might look a little shifted compared to mine on number 7, just because your axes might be drawn in a different spot. But note that my vertex is at 1, 2, 3, 4, -1. So -4, -1, our h term, and our k term. Okay? So remember it's the opposite of that, or whatever makes that 0. And then from that, since my y-intercept is it's going to be way down here. But notice y is greater than it, so I'm going to be shading up my line. If you tested 0, 0, it would give you a true statement. So that works out. How many got it? Okay. The last one's a little tougher. I factored it. I looked at it as a perfect square trinomial. Okay. If you didn't do that, if you used the opposite of b over 2a, that's something you could have went through and done as well. But in this case, and the opposite of b over 2a, by the way, would give you the same value as your zeros here, which are -1/2, okay, because your vertex lies on the x-axis. Okay, and then you shade below. All right. Any questions? Okay, everyone rate themselves 1 to 5 right now. Okay, so I'm going to be walking around. Make sure you're asking for help if you need it. Just stop me and say, hey, I need some help or whatever. We're going to be going through number 9. I want you to try that one with your groupie. And please understand, just because there are words doesn't mean that it is so darn difficult that you can't do it. I know you can do it. Give it a shot. Start by reading the words. Don't just shut down because there are words. I know. All right. So, I don't want people getting terribly frustrated just because there are words. This is just one of those situations where you have a formula where d is the braking distance and v is the velocity in miles per hour. And then they go through and then they give you an equation at the end for what speed of v so we're solving for V, would a car leave a tire mark on the road over 1 foot? So if it's over 1 foot, that means my distance is 1. And since it's over 1 foot, okay, this part would have to be greater than. Okay? So now that V squared means that we would have to divide out the 0.01875. Okay? So 1 divided by that whole chunk there. And we take the square root. Remember, when you impose a square root, it's going to be plus minus. However, would a negative velocity make sense here? No, so we'll get rid of the negative square root and just keep the principal square root. Okay? Of all of that stuff. Which gives me an approximate value of V being greater than 7 point what? And that is miles per hour. Okay. Woohoo! Any questions? Man, I am so pumped about the next part. Now, move on to the next part. Now, I tried to use this metaphor in my first class today, and it didn't work out too well. However, and someone called it a metaphor, so I'm calling it a metaphor. How many have ever been, like, to a theme park? Oh, good. All right. How many have seen one of those, like, you like know, or maybe you know of the cool ride there that everyone says they go on? Okay. And then you get there and you're like, dude, that cool ride looks kind of scary. And then you muster up the courage to get on the ride. And then once you're on the ride, you're thinking even more so. You're like, yeah, this is kind of scary. And then once you actually start riding the ride, you're like, okay, I'm kind of scared. Now, you can't just jump off the ride, right? They frown on it. I'm just saying, you shouldn't jump off the ride. Okay? Now, some people even find that they've been on the ride and they're like, oh, that's not so bad, and they start to enjoy the ride. They may even go on the ride again, which doesn't work with my metaphor, by the way. Don't go on the ride again. All right? Now, for some of you, you took algebra. Everyone took algebra. Are you just, okay, and are you just airing out your pit, Riley? Oh, hold on. I'll call on you in a minute. Okay? So some of you, everyone took algebra, and you may have actually thought, you know, that ride was okay. But that ride, I'm trying to be polite about it, okay? But you may be going, that ride called Trig or Advanced Algebra looks really fun. Okay? And now that you're actually on the ride, you might be going, this isn't so much fun. Okay? But you cannot jump off the ride. Okay? You have to stay on the ride. Now, the whole point of repeating the ride isn't good. You don't want to repeat the ride either. Okay? But I will tell you, you could try to start, if you work hard at it, you guys may actually find, well, it's not too bad, and I can kind of actually enjoy the people on the ride with me. Okay? Maybe not the ride itself. You don't have to still enjoy the ride. Now, let me point out that there's another ride that you're going to be taking, some of you, and you have a choice. Just like when you did algebra, you had a choice to repeat algebra. And I even stand up here at our parent night and I go, please make sure your student is ready to move away from algebra, because if they're not, it won't catch them in Geo, it'll catch them in Trig, which is where you're at right now. I mean, I like beg parents at parent night. And I know because I have kids, and I ask them the same question that I'm telling parents. I'm like, hey, are you sure you want to do this? Because it's not going to, I'm going through, and they have to hear it even doubly because I teach it. So they're like, no, I'm not going to stay and take algebra again. Are you crazy? I already took algebra. All my friends are going to. Then they think that I'm like stupid or something. Okay? Not the point. The point is, when you leave this course, you better make sure you have a good, firm grasp of this material. because that ride called calculus, even though it sounds really fun, and some people are like, dude, I'm in calculus. And everyone's like, whoa, you're like way smart, dude. Okay? It is tough and it has prerequisites. So make sure you're asking. Make sure that you understand the material. And then those of you not getting the help you need, make sure you start getting the help. Seriously. If you have a low grade right now, you're halfway through the semester. Almost. Or about there. You need to get in and get extra help. Okay? If you're struggling with it. Some of you are doing a good job at it. Riley? Question?
Oh, it wasn't a question. I was going to say that at around 127 miles an hour, you'd leave about a football field long tire mark.
Yeah, dude. Isn't that cool?
Yeah.
You don't want to go that fast. That's bad.
I don't think we should let Riley
All
start
right,
driving.
yes. I'm not sure. Yeah. All right, so starting with number 10. Now, since these are a little tougher, notice these are systems of inequalities. Okay, I am going to give you where I want you to put the axes.
Oh, sweet. Thanks, Chloe.
Is that at 3?
What's that?
Is that at 3? Oh.
Yeah, 3 up. Or 3 down, yeah, if you want to take it that way.
It's like 7 up. If we're getting the technical or what.
Did you say I can't count? How am I supposed to take that?
See, McCoy, what should I come in and take the quiz?
We'll probably do it during class tomorrow. After about 20 minutes in. Okay, and I'm changing the scale on this one. Okay. All right, so I want you to try number 10. Graph both those inequalities on number 10. Don't worry about shading yet.
Just beware.
What happened there? All right, so I have graphed y sub 2. How's it look?
Oh, that's
Beautiful? Nice, huh?
Glitchy boy.
Good, yes. Good catch. Well done. And I even used a pencil, so I feel very proud. Oh, yeah. There we go. We got dashed. Please note, y-intercept is 3. It's actually in vertex form. Okay, go over 1, down 3. Do I shade inside or outside this one? Greater than symbol. So I shade up the y-axis, which is actually on the outside. Now, rather than shading everywhere, and by the way, if you test 0, 0, you'd also notice it's not a solution. Rather than shading everywhere, I am going to take this outer arrow, and I am going to shade on the outer part of that arrow, like that. Okay? You just bear with me for now. All right, y sub 1, I'm going to go ahead and graph that one as well. 0, 0, I go over 1, down 1. Over 2, down 4. And it is solid.
Which makes life easy.
The longer you see me graph parabolas, you'll notice the right side of my parabolas are horrible, usually. All right.
Both of mine are horrible.
Huh. That makes me feel better.
It should.
Not really, though, because you're a student of mine. You should be amazing.
Yeah, but you've been doing this for quite a few years.
Okay, do I shade inside or outside? Come on, stay with me. Inside or outside?
Inside.
At the y-axis, I go below it, so I shade inside, which means in my arrows, I am shading to the inside. I'm shading the inside part. Now, what I'm doing is I'm looking at my arrows now. Notice the solids, or the shaded parts, are facing each other right there. That is my solution area. It is a pretty skinny area. That is my solution area. The overlapping region. Pretty coolio?
Coolio.
All right. Hey, questions? Okay, number 11. I'll come over. Notice one's in vertex form. You may want to factor this first one there. Might help you out. Hey guys, on number 10, the question came up, could I just shade out here? Could I actually shade the two different areas? And then just darken in the overlapping region? And the answer is, yes, you can. So if yours looks more like that, that would be fine. Just darken in the area where they overlap. Okay, that's fine. Y1 and Y2 there. The right side of my parabola looked okay. Okay, there's our y sub 1. Or y sub 2, excuse me. Y sub 1, I'm going to factor that. So you pull out an x. X times x is x squared. X times 5 is 5x. How is that helpful? Well, I know my zeros now are at 0 and 5. So I know it crosses right here. Or excuse me, 0 and negative 5. And right there. I know my axis of symmetry is halfway in between those. So it's at negative 2.5. Or if you used h and found it out, you'd find out it's negative 2.5. Then you plug that back in to find k. K would be actually 6 1/4.
What's going on?
All right. Our vertex is at negative 2.5, 6 1/4. Well, negative 6 1/4. So it's like right about there, I think. Thank you. Bless you. Okay, so opposite of b over 2a to find this value. And plug that back in to your equation to find that value, right? Okay. And so I'm not going to plot any more points. I'm just going to, from here, kind of sketch out my parabola. So you want it to be a parabolic curve. I don't know where it crosses anything else, so I'm not going to cross those other values. Make sure, I got to twist my page. Make sure when you finish graphing this, you note where everything shades. So this one shades inside or outside, or above or below. Above, which would be, do all that, shade lightly. Okay, are we sure we got that right? Yeah? Test 0, 0 here. Okay, if I put 0 in here, is 0 greater than or equal to 0? Okay. How about this one? Okay, guys, I made a mistake and no one caught it. Yeah. All right. So I don't want to tell you when I'm making mistakes because I really am trying. There are times when I make them. This is one of them. When I want you to catch them, well, most of the time you catch them. What have I done wrong there? Well, I've only shaded, so of course I didn't shade. I didn't shade something right, but Scarlett? I shaded on the inside of. Everyone get that? Now, right, I shaded for the smaller one and not the bigger one. So, when I'm doing this, making sure, it's important that you guys know which parabola is which as you're graphing these. It's amazing the fun stuff I can do when I'm actually using a pencil. Make mistakes and have you guys tell me what they are. Okay, so this first one, and so it's helpful if you label them. This one right here, y sub 1 is this function here. Correct? No. Good. Some of you caught it that time. Y sub 1 is this one. Y sub 2 is this one. Okay, and notice there, just like I've done on your portfolio pages, I've asked you to make sure you label the branches. You may want to label this side of it too. The outside is y sub 1, the inside is y sub 2. Okay, so now if you're testing in y sub 1, if you put 0 is greater than or equal to 0, well, y sub 1 actually crosses 0. So it might not be the best point to plot, right? We may want to plot a different one. Okay, 1, 0. So that's this point now. We're testing that one. So if I put 1 in, okay, well, let's test that one. Good point. 1, 0. Let's do the 1, 0. All right. There's 0. 1 plus 5 is 6. 0 is greater than 6 is false. Therefore, I shade to the inside and making sure we're using the correct parabola. So that means all of this. So that is narrowed down where our solution could be. Tell your neighbor where the two regions are that your solution could be. Okay, time's up. Where could they be? Go ahead. Grace? Yeah. Or Faith? Excuse me. Yeah, it could be inside either of the two parabolas. Okay, so we have to use our second one here. If we plug in, could we use 0, 0 on this one? Yeah, because it doesn't cross it, right? 0 greater than, well, that's 0 plus 2 squared. That's 4 minus 1. 3. Is 0 greater than 3? No. Therefore, we shade inside. And the overlapping region is inside. It would be right there. Total yay. Coolio. You look surprised. Not surprised. You're in awe. You're like, wow, that's amazing. Okay. Hey, I didn't get to number 12. I'm not going to worry about it right now. It would be important for, actually, since we had such a hard time on this, I want you to find the vertex on this one real quick. And find the vertex here. Okay? I'm not sure we'll go through the whole graph, but at least get the vertex for me. I just noticed if I turn this sideways, it looks like a chicken. It's got a cool hairdo. All right.
Wow.
That's not the point of the problem. All right. My vertex, 3.5. Negative 20 1/4. Okay. My vertex on this one, 3, 14. Okay. If you did not get those vertices, then we should be talking about what you're doing incorrect. Okay. Remember, this is the opposite of b over 2a. Take that, whatever you get, plug it back in here to find this. So this is f of the opposite of b over 2a, if you think of it that way. All right. Your assignment tonight. I'd like you to complete 13 through 16. Yes, I know there are words. It'll be okay. You can do it. All right. Do your best. Speed. So those of you with cat-like speed, many of you brought up the multiplier divide by negative, like 3 of you as I walk back there. So, yes, you have to flip inequality symbols when you're multiplying or dividing by a negative. Second, you are solving these, I guess that's actually first, is that you're solving these algebraically, no graphs. So you're doing this. First step is divide by 16. So x squared is greater than 116ths. Do not change it to a decimal. You like those numbers because they're both what? They're called perfects. Yes, they're perfect. So you take the root. X is greater than positive 10/4. And x is less than negative 10/4. Now remember, when you're doing a positive and when you're taking the root, you're imposing it so it's plus minus. You got to flip that sign there. Okay? I can simplify it further. Is that what you're going to say, Derek? Yeah, you can call this 5 halves. Yeah. For sure. Okay, so, yeah, probably would want to write it as 5 halves and negative 5 halves. Cool? Can x be greater than 5 halves and less than negative 5 halves? Is it possible for x to be greater than 5 halves and less than negative 5 halves? No, so this is called a OR situation. Okay? Oh, yeah, I remember too. I taught it a few periods ago. Woohoo! All right. Finish those